Now let us look at the third question. F from R tends to R given by f of x equal to x square. Okay, right? So here this is from R to R, real number set to real number set. Okay, so different real numbers have different results, different squares? No. So here also we can judge whether that given function is 1 1 or not. For example, if you take plus 2 4, minus 2 also, minus 2 square 4. Okay, so we can take plus 2 also, minus 2 also, because domain is real number set. We may take any value. Okay, and we may take 1 by 2 also. If you take plus 1 by 2, 1 by 4 is the result. If you take minus 1 by 2 also, result will be 1 by 4 only. That means two elements are having same image, correct or not? So it is not 1 1. Okay, so like that, first of all we have to understand the question. So then we'll go for proving theoretically. How? Let x1 comma x2 belongs to R, any two elements in the domain. F of x1 equal to f of x2 will take. From that, x1 square equal to x2 square. That implies x1 equal to plus or minus x2. What does it mean? For one element we are having two images. Otherwise, see, x1 equal to plus or minus x2. We are not getting different elements have different images here. F of 2 equals to f of minus 2. By substituting 2, what will get? 4. By substituting minus 2 also will get 4. But whenever f of x1 equal to f of x2, those x1 x2 are not equal. See here, 2 not equals to minus 2. Correct or not? Their results are same, but those elements are not same. Okay, it's very simple to understand. Okay, in other way also, for two elements we are having same image, so it is not 1 1. Actually, for 1 1, different elements of domain should have different images in the codomain. Clear? Now, so if it is not 1 1, now let us take on to. For that, we should take one number from the codomain in place of y. Let y belongs to R, any real number from codomain. F of x equal to y will take. What is f of x here? X square equal to y. X equal to plus or minus root of y. So here also, in place of y, can I substitute negative number from codomain? What is codomain? R. Can't I substitute negative number? Okay, if I substitute any negative number, for example, let us say y equals to minus 2. Root minus 2. Root minus 2 exists in real number set? No. Okay, root of negative number does not exist. Root of negative number leads to imaginary numbers. Clear? That means for every y belongs to R, are you getting any pre-image in the domain? No, that does not exist. Any x belongs to R. Therefore, f is not onto. By this, what can I understand? F is not bijective. Clear? So it is very easy to understand. For 1 1, different elements of domain should have different images in the codomain. For onto, every element of codomain, we need to have at least one pre-image in the domain. Clear? So let us go for fourth question there. Now, here, f from n tends to n by f of x equal to x cube here. Okay, f of x equal to x cube. For 1 1, let us take two numbers, x1 comma x2 belongs to n. Before proving like this theoretically, first of all try to understand. By substituting different natural numbers, will you get different cubes or not? By substituting different natural numbers, will you get different cubes or not? Otherwise, are you getting any common answer for any two numbers? One cube, two cube same. So like that, cubes of any two different numbers as same we get? No, that is not possible. Correct or not? So different natural numbers have different numbers as their cubes. Correct or not? 1 cube 1, 2 cube 8, 3 cube 27, 4 cube 64, like that. For different numbers, if you substitute, will get different results are their cubes. Correct or not? So that means, so we can say it is 1 1. Okay, so theoretically, formally how can you prove? Let x1 comma x2 belongs to n, f of x1 equal to f of x2. That implies x1 cube equal to x2 cube. That implies x1 equal to x2. So different natural numbers have different numbers as their cubes. So different elements of domain have different images in the codomain. Correct or not? So f is 1 1. Clear? So now let us go for checking on 2. Let f of x equals to y. That implies y equal to x cube. Y equal to x cube means what about x value here? X equals to cube root of y. Okay. So cube root of any number lies in natural number? No. That we have to understand first. Okay. So proof is very easy. Okay, to write. So what is the value of x here? We got in terms of y, cube root of y. Acha, in place of y, if you substitute any number from codomain, what is codomain there? N. Domain also n only. For every y belongs to n, if you substitute any natural number in place of y, so cube root of that natural number lies in again in natural number set? No. Okay. See, that's what. For every y belongs to n, there does not exist any pre-image in the domain. Correct or not? In the domain. In the domain. Okay. From codomain, if you substitute any number, okay, codomain means n. Domain also n here. So pre-image the domain. If you substitute y equal to 2 there, so what about x value there? Cube root of 2. Cube root of 2 in decimals only. So that decimal, do you have any decimal values in natural number set domain? No. So cube root of 2 does not belongs to n domain. Clear? So therefore f is not on 2. Correct or not? So therefore f is 1 1 but not on 2. Correct? So if any or either of them does not satisfy, f is not bijection. So clear? Hope you have understood. So now we'll go for next problem.